All right, good day. Hope that you're doing good. So now in this video, we're going to be looking at the previous question paper relating to 3 and 2D trigonometry. So now these questions that I'm going to solve for here, they are from your 2021 November previous question paper, paper 2, right? So now starting off with the first question. Now the first step, I'm going to try and redraw this on my answer book as the question has instructed me to do so. So this is R, and this here was meant to be Q. This here it's P. And now next, because this line is opposite to my angle P, I'm going to represent it with a small letter P. And because this PQ line is opposite to my angle R, I'm going to represent it with a small letter R. And because this line RP is opposite to my angle Q, I'm going to represent it with a small letter Q. Right. Now, second step, it's construction. So I'm going to construct line RM, right, such that my line RM is perpendicular to my line PQ, right? And I'm also going to join M and P to form a line. So let me go about doing that. So here, this would be my R, this would be my point M. And I said I'm going to join MP. And I said this line RM is going to be perpendicular to this line PQ. So here it needs to be at 90 degrees. All right. Now, also, I am told that in triangle RQP, right, P is an obtuse angle, right? Meaning that this angle right over here, let me just indicate it using a different marker. This angle right over here is an obtuse angle. It's greater than 90 degrees. Now, I'm going to try to make use of that information, right? So now, basically, in order for me to find this angle here, which is RPM, right? Angle RPM, this is the same as 180 minus P, right? Remember, because this here was angle P, right? So this here, it will be the same. Okay, let me just try and write that. 180 minus P, right? The angle here, this is my angle RPM. Now, taking that into consideration, let us go to the proof, right? So basically, I'm going to start with naming the first triangle that I'm going to be working at. I'm going to be working at the smaller triangle, which is triangle RPM. So RPM, this right angle triangle right over here. So now, in that triangle, I'm going to try to find my sine. Because remember here, I must prove my final answer should include sine. So I'm going to say, okay, sine of our angle P, which we have just calculated as 180 minus P, this angle right over here, right? It will be our opposite. Now, the line that is opposite to the angle is RM over our hypotenuse, which is the line that is opposite to the angle 90 degrees, which is RP. And we said this line RP, we're going to indicate it with a small letter Q. So I'm going to write Q right over here. Now I'm going to try to make this in terms of RM, right? And how am I going to go about doing that? By simply multiplying both sides by Q. So if I multiply this sides by Q, my RM is equals to Q multiplied by sine. But remember, this angle P right over here, right? This angle P here, we have calculated it as 180 minus P, right? Now, going back to our cast diagram, right? We need to reduce this. So if I were to draw my cast diagram here, 180 minus X, it's in the sine quadrant, meaning that sine is positive in this quadrant. So basically this sine 180 minus P, it is the same as positive sine P. All right. Now simplifying this further, let me go about doing that. My RM would be equals to Q multiplied by sine of P. All right. Now the second step. Now for the second step, I'm going to be using the other triangle, but now I'm going to be using the bigger triangle. Which triangle am I referring to? Let me just try and highlight it here. So now I'm going to be using triangle RMQ, right? So triangle RMQ. So I'm also going to be using the sine ratio because if you could look at RMQ, this is a right angle triangle, right? So I'm going to say, okay, my sine of Q in this case, it is equals to the line that is opposite to angle Q, it's RM, all over our hypotenuse, which is that line that is opposite to our angle 90 degrees. And in this case, it's RQ. And we said RQ, we're going to indicate it with a small letter P. Now, last step, we're going to try to make everything in terms of RM by simply multiplying both sides by P, right? So if I multiply this side by P, so as a result, our line RM, it will be equals to P multiplied by sine Q. All right. Now, the final step, as you could see here, we have RM, which is equals to a different equation. Same applies to this side. We have Rm, which is equals to a different equation. Now we're going to equate these two together because they are the same as Rm. So basically now doing the last step. So now I'm going to say, okay, Q multiplied by sine P. This is equals to P multiplied by sine Q. All right. Now the final step, right? I'm going to divide both sides. Now this is important. Let me just try and write that down. So the final step, when you arrive to this stage, you're going to divide on both sides by, so we're going to divide on both sides by sine P multiplied by sine Q. All right. So we're going to do that on both sides. So basically, let me go about doing that. So I'm going to divide this side by sine P multiplied by sine Q. What I do on the left, I must also do on the right. Sine P multiplied by sine Q. All right. Now, note that if we do that, what's going to happen is that on the left-hand side, the sine P is going to cancel out with the sine P. So you're going to be left with Q over sine Q. This is equals to, now on the right-hand side, the sine Q is going to cancel out with the sine Q. You're going to be left with P over sine P. And this is what the question was requiring us to prove, as you could see here, right? So basically, that would be your final answer here. Right, now let us move on to the next question. Now moving on to 7.2, they say from I, the angle of elevation to the top of the vertical pole KL, it's X, alongside the gentle slope KI from point J, D meters closer to the tower, the angle of elevation is Y. All right. Now, basically, it's an explanation of this given sketch right over here. Now, let's see what the question is requiring from us. Now, the question 7.2.1. So let me just change the color of my marker here. So 7.2.1 shows that the height of the tower, which is this H, it can be given by this equation right over here. Now, the first thing first, I'm going to try to work in this smaller triangle, right? And try to prove, because you could see here, I have my sine identities, and I'm also going to try to put my h in terms of sine using the first small triangle. So because this line or this line here, Li, which is indicated with the letter J, it's opposite to this angle right over here. I'm going to refer to this as angle J, all right? But then you can put any value. I just choose J, all right? Now, I'm going to be working on triangle LJK, right? So this is my LKJ, which is a right angle triangle. And as I've said, I have my sine identities in the given question, or rather, what I'm trying to prove. I have the sine equation. So also I'm going to try and represent my h in terms of sine. So first thing first, I'm going to say my sine of angle Y, right? Which is this angle right over here. This is equals to my opposite, which is line LK, represented by the letter H, over my hypotenuse, which is LJ. Right, and now I'm going to try to put this in terms of height by multiplying both sides by LJ. So that my height, it is equals to LJ multiplied by sine Y. All right, now this is the first step. Now the second step, I'm going to try to prove for this line LJ, right? And I'm going to do that by using the other triangle. So let me just try and clear this up here. So I'm going to use this triangle LJI. Right, and because as you could see, this triangle LJI is not a right angle triangle, it means that I cannot use my trig identities. So let me first name my triangle right over here. So here I'm using triangle LJI. So now I'm going to try to solve for my LJ, right? Using, remember my sine rule, right? A over the sine of A is equals to B over the sine of B. I'm going to make use of this rule, right? Now, my line LJ over the sine. Now, what is the angle that is opposite to this line LJ? It is this angle X right over here, right? So over angle X. Now, this is equals to, so let me equate it. So now I'm also going to make use here of this line JI, which I'm given as D, right? So I'm going to say this over JI, which is indicated with D, this JI over sine. Now, what is that angle that is opposite to this line JI? It is this angle here, L1, right? Sine L1. All right. Now, as you could see here, I have the angle X. I am looking for LJ. LJ is the only unknown. And on the other equation, my L1 is unknown. Now, let me see if I can be able to solve for my L1. Now, taking a look at the diagram we're given, right? This is our L1. Now, can you see this angle Y? Right. This angle Y is an exterior angle of a triangle. And what do we know about your exterior angle of a triangle? It's equals to two opposite interior angle. Basically, this is equals to that plus that, right? So I'm going to write here that my angle Y, this is equals to angle L1 plus angle X. And my reason is that this is an exterior angle of a triangle, right? Now, remember, I'm trying to solve for my L1. So as a result, my L1 would be equals to Y minus X. Right, as you could see, I have something like that here, meaning that I'm in the right direction. So now let me just try and rewrite this very well here. Now I have solved for my L1. So basically LJ over sine X. Remember, I'm trying to solve for LJ. This is equals to line D over sine Y minus X. And now what would be the next step from here? I'm trying to solve for my LJ. So I'm going to multiply both sides by sine X to get rid of the sine X here. So as a result, my line LJ would be equals to D over sine Y minus X multiplied by sine X over 1. All right, now remember this is my equation 2. On the first equation, right, I said my H, right, this is my first equation. Let me just try and highlight it. This equation right over here, I said my H is equals to LJ multiplied by sine Y. Now I found my LJ. Let me try and substitute it here. So basically, here, to simplify things further, you can multiply numerator by numerator, denominator by denominator, so that your LJ is equals to D multiplied by sine X all over sine Y minus X. All right, so now substituting here, my H would be equals to my LJ. Now remember, this is my LJ. And my LJ is D multiplied by sine X all over sine Y minus X. And all this is multiplied to sine Y. All right, now let me see how is my final answer. All right, so meaning that my final answer would be equals to, my H would be equals here, numerator by numerator, denominator by denominator. It will be equals to D multiplied by sine X multiplied by sine Y all over sine Y minus X, which is what the question was requiring us to prove right over here. All right. Now, let's move on to the next question, 7.2.2, right? They say calculate the height of the tower if D, now they're given us the value of the D, right? So they say D, it's 70 meters. So now this is the formula for our height. Now, the given information, I'm going to try and write it here. They gave us the length of D as 70 meters. What else did they give us? They gave us angle X, which is equals to 12. And they also gave us angle Y. They said it's equals to 30. And the question is requiring us to calculate the height. All right, so we're just going to substitute these values into this equation right over here. So now let me go about doing that. So basically my H is equals to my value of D, which is 70, multiplied by sine of 12, multiplied by sine of 30, all over sine of 30 minus 12. Right, now let me try and punch that into my calculator. Now, Punching this into my calculator, my height would be equals to 23, rounding it off to 2 decimal places, 55 meters. All right. And that will be all for this question. Remember, if ever you have any questions, always feel free to reach out. Thank you.